I don't know. I don't think it really matters.
Okay, let's open 236 here with Paint. And if this is the last one, I can close it out real quick and
Oh, that's the right one.
that's the right one, okay.
Yeah.
Okay, solve for C. Do you have any problem with this one?
I don't think so.
Well, let's see. Let me write on this and let's go through that. It's hard for me to see what your answer is. Just a second.
Yeah.
Just a second here. This is pretty straightforward. You got F minus 32 equals 9/5 C. And I can do that in one step by now multiplying both sides by 5/9. So I got 5/9 times F minus 32 equals C. And I guess I need to distribute that. Not really, though. You could give that as an answer, couldn't you?
Yeah.
Okay. We don't need to distribute it then. But it looks like I'm going to end up with 160 divided by 9 as one of my answers. In other words, the other way I might write that would be this. That's also C. Okay?
Yeah.
Okay, let me erase all that and solve for H.
Yeah, this one I finished.
Let me start from the top here. S equals 2 pi RH plus 2 pi R squared. Now, when you're solving for, in this case, H, the goal is to get everything without H on the other side of the equation, and then get everything that's multiplying H out of there. So what's the first step? What's the next line I'm going to have here?
So I think you'd subtract the 2 pi R squared. So it'd be 2 minus 2 pi R squared
I think
equals...
it's S minus, yeah.
Oh, yeah.
Okay, and that's going to be equal to 2 pi RH. Now what?
You can divide the 2 pi R from 2 minus pi R.
Gets rid of it over there. We've just solved for H. And that's a perfectly fine answer.
Can you, no, never mind.
Okay. Oh, you were going to ask, should I break that up into two fractions?
Yeah.
In other words, you could. It's not incorrect, but I don't really see a need to. In other words, unless it's multiple choice. So there's that, and then minus, this would just be R. So this is also a possible answer. I don't know that it's necessarily a better answer. Like I said, unless you were looking at multiple choice answers, you might find this one on the test and not that one. I need to close this out, reopen it so that my pen works. Here, let me scroll down first. You have any problems with adding or subtracting?
Not really.
Okay.
You just...
Tell me what 8 is. Just.
Would 9i just be -9?
When you are adding or subtracting, what you do is you add or subtract the real, and then you add or subtract the imaginary. Okay? So the real is really 0 plus 9i. So if I'm subtracting the real, I end up with plus 9. Try something here. In other words, adding, subtracting, multiplying, just treat the I like you would any other variable. Okay? What's the, so that first part is going to be 9. What's the rest of it?
9 plus 9 minus I.
No. In other words, here's what we're looking at. If I can figure out how to write this. I got 0 plus 9i, and then I'm subtracting from it minus 9 minus I. So subtract the reals, gives you the plus 9. Combine the imaginaries. What is plus 9i plus 1i?
So that's 10i.
Yeah, plus 10i. And I have it in A plus BI format, which is the way you always want to put your answers when you're giving a complex number.
Oh, so, okay, I get it now.
You get it? In other words, it doesn't matter what the two complex numbers are. They can be anything. Just combine the reals and then combine the imaginaries. Same thing with adding. Same thing with multiplying. How do I multiply number 10?
You would do -3 times 3.
So that's -9.
So -9, and then you do. Would you FOIL or would you just keep?
Just FOIL it.
Okay, so it'd be -9 minus 3i minus 15i minus 5i squared.
The only tricky part is the I squared. Notice that those two will combine. What's I squared equal to?
-1.
Okay. So now we have minus 9 plus 5. So the number part is minus 4. Combine the i's. You can't do anything about changing those, so that's 18i. Again, our answer is in A plus BI format.
And that's the correct form?
Yeah.
Okay.
Unless I did the math wrong. But no, you're going to have minus 9 plus 5. Yeah, because I squared is a -1.
Okay.
All right. So, that's interesting. I can write down here and figure out what's going on with my tablet here. Perform the indicated operations on number 11. Well, FOIL that just like we did. FOIL that just like we did. And then you're going to be subtracting two complex numbers. So it becomes the same problem as that. Okay? Now, the only ones that are hard, well, not really hard, but have some degree of difficulty, are division. So let's go down and look at the division one. It's not really a division problem. That's the secret. If I give you 1 over square root of 2, is that a division problem?
No.
It's a rationalize the denominator problem, right? Same thing with complex numbers. When you have a complex number in the denominator, mathematicians do not like it. So they want you to get rid of it. They want you to turn it into a real number. And there's a way to do that, just like there's a way to rationalize when you have a fraction with an irrational denominator. And what you do is you multiply top and bottom by the conjugate of the bottom.
So it'd be 1 plus I?
Yeah. So 1 plus I in the numerator and 1 plus I in the denominator. And what happens when you multiply a complex number by its conjugate? It turns real. In other words, if I FOIL that, 1 minus I times 1 plus I get 1 minus I squared, or 2.
Mm-hmm.
In the numerator, I've also got to distribute. I got to multiply 2I times that 1 plus I. So I get 2I plus 2I squared.
So it'd be -2.
Which gives you -2 plus 2I all over 2. Now I can divide top and bottom by 2, and I get -1 plus I. That's the answer.
Okay.
You see how?
Yeah, I made the 2I squared -2.
Don't forget to simplify it, because you do have a 2 in the denominator. When I multiplied this denominator together, that times that, I didn't get 1. I got 2. I got 1 minus I squared, which is 1 plus 1. So I do have a 2 in the denominator.
Mm-hmm.
The fact that I have a 2 in the denominator means I can cancel out both of these 2's in the numerator. In other words, I can divide top and bottom by 2. Once I get to this step right there. Now I can divide top and bottom by 2, and I end up with -1 plus I.
Mm-hmm.
Okay. 13, what are you going to multiply it by?
5 plus 3I.
Yeah, as long as make sure you do bottom and top. And you won't get rid of the imaginary number in the numerator. But that's okay. You can have a complex number in the numerator, just don't want one in the denominator. Just like you don't ever want an irrational number in the denominator. Unless you're studying trig and the trig teacher says, don't worry about rationalizing denominators for this trig course, which is what most of them say anymore. How are we going to do 14?
So you can change square root -32 into
Into what?
you can change it into 4 square root 2. So 4 square root 2I.
4 square root of 2I.
Yeah.
Okay, so here's what we have. We have 2 times 4 square root of 2I, right?
Mm-hmm.
Which is 8 root 2I. So
Yeah.
that's what the thing on the left is. And what can I do to the thing on the right?
It would be, you could take the square root of -18, which would be 3 square root 2I. So that'd be 15 square root 2I.
Now I got apples and apples.
Mm-hmm.
So what's the final answer?
So this would be 23 square root 2I.
Yeah, I'm just discovering that I can write at the bottom. It doesn't give me all this crap that I get over here. Huh. Interesting. That's all the problems on that page, I gather?
Yeah.
Okay, let me open the next one. Okay, that's just multiplication. We're going to convert those to i's first. And incidentally, it's fairly important to convert them to i's. You have been taught something that isn't quite true for a number of years. That is this does not apply. Hold on. Grief. What in the world? Hold on. One thing you got to be a little careful of. That is not the square root of a times b.
Mm.
In other words, because you've always been taught that the square root of a times the square root of b is equal to the square root of ab, right?
Mm-hmm.
Does not apply to complex numbers. In other words, and that is what we're presented with in this problem here. So when you FOILed it, you got that. And let's see, that was root 2i. That was root 3i. I don't think we FOILed it quite right. Here, let's FOIL this again. The 12 is correct. Okay. The second term, well, that's root 3i times 6.
Root 3i.
Yeah. You see why? Here's what I always do with these problems. I always break it up and I take the -1 out first. That's how I do it. You'll never go wrong with that technique.
Mm-hmm.
Well, that's I, that's root 3. So that's root 3i. You with me?
Yeah.
Okay. So now when I do 6 times root 3i, I actually get 6 root 3i right there instead of that. And then when I do 2 times root 2i, I get 2 root 2i right there.
Mm-hmm.
And then I do get 6i squared, which is -6. Always convert your I squareds. And now the 12 combines with the -6 to give me 6. How do I add these? I guess the answer is, root 3i and root 2i is 12 root 6. Of course, I'm going to multiply that times that, and I'm going to multiply that times that. Oh, I'm not multiplying, I'm adding. Excuse me.
Mm-hmm. I think that's the furthest you can go.
Yeah, I think you're right. In other words, I've got 6 root 3i plus 2 root 2i. And I guess I could factor out the I, so that if I want to put this answer in a plus bi format, here's what it looks like. 6 plus and now that's A. That number is B.
Mm-hmm.
6 root 3 plus 2 root 2. So
Yeah, I don't.
the answer would be right here to this problem. And you're right, you can't combine those. You can't combine a root 3 plus a root 2 without converting it to decimal, which you lose the accuracy of it. So that's the answer they're going to be looking for. Okay, you good on number 15?
Yeah.
Okay, let's go to 16. Let me scroll down a little bit here. Whoops. I scrolled down too much. Okay. So tell me what to do on 16.
Would you start with dividing, or would you do the square?
I always start with converting that square root of a negative number to some number of I. So let's talk about this. What is the square root of minus 72 equal to?
Can break that up into 9 and 8, so 3 squared.
There's a better number to factor 72 with. Here's a tip. Always use the greatest, the largest perfect square number as a factor, if there is one. And notice that 36 is a factor of 72. So I can write it like this. There's the negative 1. I always do that. Times 36 times 2. Which gives me 6 root 2 I. With me? So now I've got minus 12 minus 6 root 2 I all over 6. Give me the final answer.
It would be negative 2 minus 2i, the square root 2i.
Yeah. And if they want all of their answers in a plus bi format, then you do have to break that up into two fractions. In this particular case, I can think of it as just dividing top and bottom by 6. But even if this was a 5, I would want to break it up. You see what I'm saying?
Yeah.
In other words, the answer would be minus 12 fifths minus 6 fifths times root 2i. That would be my final answer if that denominator was a 5. So you always have to split it up into two fractions, even if it doesn't divide evenly, in order to get it into a plus bi format. Again, that's A. That is B. Actually, negative 6 fifths root 2 is B. You good on this one?
Yeah.
I think I have to reopen it to get to the next one. I screwed up there. All right. Solve the equation by factoring. Well, let me try just writing on their thing. It seemed to work a little bit better. So what's the next line?
It would be 8x squared minus 55x minus 7 equals 0.
Okay. Can't take out a greatest common factor, so we're going to have to live with that big number 8. Most likely way this factors. In other words, it's kind of trial and error at this point.
Probably a 4 and a 2.
That's what I would start with. 4x and 2x. What are the signs?
Plus and minus.
And because those coefficients are different, I got to allow for both possibilities.
Mm-hmm.
And 7 only has one set of factors, 7 and 1. So those are the only ones I have to try. Obviously, I'm not going to get up to 55 trying 7 and 1. Even the 7 multiplied by the 4 only gets me up to 28. So I'm going to have to use 8 and 1 instead of 4 and 2.
Mm-hmm.
So it's 8 plus or minus times x minus or plus. And now the 7 looks like it needs to go right there. The 1 needs to go right there. That gives you the proper middle term.
Mm-hmm.
So what are my two solutions?
The solution, it would be x equals 7 and 1.
The 7 is correct.
Oh, 7 and negative 1. Sorry.
No. In other words, what you're doing is setting that equal to 0. That whole thing. 8x plus 1 equals 0. Solve that. That's always what you're doing. Whenever you're solving an equation by factoring, and you get it into two factors, multiply it together that equals 0, you solve it. You finish solving it by letting each one be 0 and solving it for that. This one gives you minus 1/8.
Mm.
See how?
Yeah, because you'd have to
The
divide.
1 over, it becomes minus 1, and then I got to divide both sides by 8.
Mm-hmm.
So be careful of just using this number as your answer. Because if there's a coefficient in front of the x, it's not ever going to be correct. Let me see here. Oh, good. It's the best way to do 18.
18, you do the same thing?
No? What is 18 missing that 17 had?
Oh, they had a 7, and that one has 0.
Constant. They had a constant. This one does not have a constant. So I can actually factor it in its current form. What's my first step in factoring that on the left? Always your very, very first consideration whenever you're factoring anything, for whatever reason, is greatest common factor. So is there a greatest common factor here?
No.
X.
Oh, yeah, you can take the x out. I need that.
Now you got two things multiply. I apologize for this. I am not sure what I'm going to do to fix it. But now you got two things multiplied together equals 0. So what are my answers?
Your answers are, 1 sec.
There's two of them, and it's a quadratic, so you got to find two solutions. I'm not sure why everybody makes this mistake, but they do. What's one solution? Give me the simple one. Set 12x minus 7 equals 0.
12. 7 over 12.
Okay, that's one solution. What's the other solution? Remember, if I'm multiplying two things together and they're equal to 0, I'm going to set both of those things equal to 0. So what's my second solution besides 7/12? This one right here. Set that equal to 0.
0?
Yep.
Oh.
Ignore the 0. Notice the problem. If x is equal to 0, that is a valid equation. Also, if x is equal to 7/12, that is a valid equation.
I guess that makes sense.
But this one, most students miss that. I'm not quite sure. If it doesn't have a number with it, they don't see it. In other words, if it was x minus 2 times 12x minus 7, you'd see that there's two solutions. But for some reason, when it's an x all by itself out there, or an x squared even, people don't want to look at that solution. But it's valid. Okay, I'm going to, whoops, I'll scroll down and try using my other pen in a different manner here to do this. Hopefully this will work. Okay, what am I going to do for number 19?
You'd start with the square root.
Okay, so what's the next line?
2x plus 3 equals 5.
Now, whenever you solve an equation by taking the square root of both sides, which is what you just did, always, always, always begin your answer with the words
Plus or minus.
plus or minus 5. And it definitely matters. It gives you one other solution as opposed to the one you would have gotten if you'd have just used plus 5. Okay? So now go from there.
So then you just solve the equation.
Well, 2x plus 3 equals plus 5, or 2x plus 3 equals minus 5. Now you solve each equation and you get x equals 1 or x equals, let's see, minus 4. So your two solutions are those two right there. And if we plug in 1, we get 2 plus 3 squared is 25. And if we plug in negative 4, I get minus 5 squared is also 25. So both solutions work. Okay. Number 20.
You take the square root of x plus 5 and square root of negative 4. So you get x minus 5 equals plus or minus 2i.
Good. Now what?
And then x minus 5 equals 2i, and x minus 5 equals negative 2i.
Okay, I'm going to jump a step. There's one solution. There's the other solution. And that's always what plus or minus means. You just have two things that you wrote it only once. Okay? Let's scroll down more. It does seem to have helped my ability to write. Now, hold on. Gotta do this first before I can scroll. Okay, solve the equation by completing the square. It's 10 after 5. You tell me when you need to go. You said 15 after?
Yeah, that'll be fine.
Okay. So, what am I going to do to complete the square?
So you would do x squared minus 14x equals negative 13.
Leaving enough room to complete the square, like that. Now what?
Then you take half of 14, which is 7, and then you'd square it, so you'd get 49.
And now you got to balance. How do I balance?
Then you do negative 13 plus 49 on the other side.
Now rewrite this as a linear binomial term.
x minus 7 squared.
Yep. That's the whole point of completing the square, is so that you can write that as a binomial term. Now what?
And then you do the square root of both sides.
Okay.
So it'd be x 7 equals 6
Nope.
equals plus or minus 6.
Now give me both solutions.
X equals 13 and x equals -1.
Good.
Okay. I think
You need
that's
to go.
yeah.
When you, let me just add one word. On 22, you move the 6 to the other side, but then you cannot complete the square until you factor out a 3 from the left side. Know what I'm saying?
Yeah, would you make
It's going to look like 3 times x squared minus 2/3 x equals 6. So it's going to translate to 3 times x squared minus, I'm factoring out a 3, leaving room enough to complete the square, equals plus 6. Now I can actually divide both sides by 3, turning that into a 2. And now continue on your merry way. Complete the square inside, balance, take square root of both sides, everything else is the same. Just remember that when there's a number in front of the x squared, you have to factor it out before you can complete the square. All right. Joseph, have a good rest of your evening, and I will talk to your sister here shortly.
Thank you.
You're welcome. Bye-bye.
Bye.